So the way I will go through this is that I will talk about some nice features that Snakemake, which is a workflow management system, offers you in order to get your pipelines going in a nice and sustainable way. And this will cover topics that might be of interest to both people who have never heard of Snakemake before, but also to people who maybe are already working with Snakemake or comparable workflow management systems and would just like to maybe learn more or ask questions about specifics they had issues or problems with. So throughout the talk, I'd be happy if you have any questions or any comments about anything that I'm saying. You can just go ahead and interrupt me and ask right away. So as an introduction, why do I want to talk about Snakemake right now? Well, first of all, it's always great to talk about Snakemake and how to get how to make our pipelines more sustainable. But also another reason is that since the last publication on Snakemake in, I believe, 2012, we have just recently submitted a new updated version of the manuscript to F1000. Which describes many new features which have been introduced to Snakemake recently and which make using Snakemake in order to make data science and data science analyses more sustainable much better. And in order to make this a little bit nicer to understand, first of all, here you have the slide where in the bottom you can first of all see the link to the preprint, which is currently hosted on Zenodo, and then also the link to the Snakemake GitHub repository where all the development activities are taking place, because Snakemake is an open source software with an MIT license. And also, as you can see in the third link, and at the bottom, snakemake.readthedocs.io has extensive documentation. Now, I already hinted at the fact that Snakemake tries to allow you to make your data science analyses sustainable. So sustainability in data science is maybe not the most common word that you hear everywhere. Most often you just hear that you want to have your research to be reproducible. And we are trying to generalize this concept by saying, yes, reproducibility is great, but what we also require in order to reach sustainability, that is having a reproducible, adaptable, and transparent way of doing your data science, is basically these three pillars that I've just mentioned, and then also 6 further properties that are of utmost importance. So what do I mean by these? Well, reproducibility, I guess you can already imagine what this means, really, that if you have a paper which produces some results, you should be able to reproduce these results from the raw data yourself. What is needed for this? Well, first of all, automation, meaning that you don't want to have to manually move around data, execute scripts manually in some order that you have to think about, but preferably you just want to execute a single command and that's it. In order to be reproducible, your data analysis workflow also needs to be scalable. That is, it needs to run on different execution environments, different clusters, local laptops, your Raspberry Pi maybe, depending on where you live and what you're working on. It needs to be portable. All the software dependencies needed to run your pipeline need to be readily available in the correct versions. That's the first column. That's reproducibility. We do also require adaptability, which again depends on scalability and portability, but also requires your pipeline to be readable. That is, a person who has not developed it him or herself needs to be able to take a look at it and understand what is actually going on, both on a technical level, that is, the pipeline is working from a software engineering point of view, but also on a methodological level, meaning that all the parameter choices and so on are reasonable. And this immediately brings us to the third pillar, which is transparency, which first of all, again, requires readability. That is, you can understand what is going in the pipeline, but also traceability of the parameters used to execute the various tools. And it also needs a feasible documentation, which allows you to understand what is going on without having to look at the actual source code. For example, if you are a domain expert, but don't have the knowledge to program the pipeline yourself. And we argue that reproducibility, adaptability, and transparency put together allow you to produce sustainable data analyses. And this is the reasonable goal for the future moving forward, where data becomes more and more ubiquitous in our analyses. So before I go into actual features that Snakemake offers you, I just want to give you a really broad overview of what is currently out there. If you, for example, go to this awesome list of pipelines, it already lists over 150 tools that, first of all, can be broadly split into tools which need a graphical user interface, such as, for example, Galaxy, which probably most of you already know. You have this nice web interface where you can click and drag around boxes, connect them with arrows, and quickly share your analyses with other people. That's nice, of course, very user-friendly for people that want to get to know how automated pipelines work and so on. But I guess I don't have to go into the details of what's good for GUIs and what's good for textual interfaces. So the second general approach, as I said, is to not have a GUI, but to simply define everything as a text file. And here you basically always have the trade-off between having a high degree of flexibility, but at the same time, a very high level of complexity as well. For example, you have tools such as SciPy, in which you basically just use your programming skills in the programming language Go, and then have certain classes that make it easy to define workflows by just defining a workflow variable, assigning processes that transform some textual data, define the data flow, and then just run it, all within the programming language Go. So you have a high flexibility because you literally program, but it's also quite complicated because you have to know how to program in Go. Somewhere in the middle, you have domain-specific languages such as Snakemake, which I'm going to talk about, and for example, Nextflow, which is based on Groovy, which is some Java derivative. And as you can see here, it's not literally Groovy, but you rather have some components that are usable and very often used in data science analyses, just readily to be used. So for example, here for processes, you have these process split letter components, and then everything is just nicer and less complex than actually programming everything yourself, but you also lose a little bit of flexibility. And then on the other side of the spectrum, you basically lose all flexibility because you're not programming anymore, but you have static configuration files, like for example, YAML files here. But again, it's very easy because, well, you're not programming, you're just putting some keywords in a YAML file. And then as a kind of special case, you also have common workflow languages, which are also specified in YAML. And here the idea is really that you are not dependent on an execution engine. You can, for example, use something like Tibano or Cromwell, which really allows workflows defined in the common workflow language to be run on any execution environment, any cluster that you can think of. Now, I already said that Snakemake uses a domain-specific language, meaning that it falls somewhere into the middle of this trade-off between complexity and flexibility. And we believe that this is really, in some senses, of course, you can always discuss this, but kind of the optimal trade-off between these two components, flexibility and complexity. And to just give you a really quick introduction to how Snakemake or basic Snakemake pipelines can look like, here on the left side, you basically have a snake file, which is always the starting point when you're dealing with Snakemake workflows. And the idea is always that you have the very first rule, which is commonly called the rule all, and this defines a certain set of input files. So what this expand function really does, it just substitutes the sample wildcard with the values back here from the list. So what this initial rule takes as input is a.txt and b.txt. And what Snakemake is then doing is that it basically tries to figure out through the output and input connections it knows from other rules how to generate the files a.txt and b.txt. It does so when you simply execute Snakemake with some number of cores, and then it will transform this list of rules into a DAG of jobs. And as you can see here, we already saw that in our rule all, we want to somehow produce a.txt. Well, how can we produce a.txt? Well, the rule all has at output sample.txt. So if we just substitute a for sample, we know we can get a.txt from this if we somehow get the input a.csv. Well, how do we get a.csv? We can see that the rule download, in fact, provides a.csv without any input. So Snakemake is satisfied and said, yep, that's how I can generate a.txt, and I'm good to go. And this job DAG, so directed acyclic graph, is really visualized here on the right side. Now, This is great and this is really nice. And this already enables you to do many, many things. But also, in order to organize your workflows in a reasonable way, Snakemake kind of tries to give you a best practice of how to put, of where to put all the files that you require in order to make everything as understandable and traceable, documentable, and readable. So as transparent as possible. And first of all, because this is really something that you should always do whenever you have the choice to, because we just have text files. So the snake file is just a text file, your typical scripts and so on are also going to be text files. You can track everything by your favorite version control system. Probably most people here like using Git. Modular rule definitions. This really means that the snake file that we just saw, which you can see here on the left, does not have to contain every single thing that goes into your workflow, but rather you're able to kind of spread it out a little bit. And I'll talk about that later on in more detail. You can have isolated software environments, for example, using Conda, which makes portability to other execution environments really easy. You can automatically generate reports of what has been going on in your pipeline, which just makes transparency and just understanding what's going on in your pipeline really, really easy. You can validate your configuration files needed to define what inputs to use, for example. I'll talk about that later as well. And then you just have some commonly used folders where you store your generated files and common annotation files, for example, that you would use in your pipelines. Now, I already hinted at the fact that there are different layers of modularization that you can use in your Snakemake workflows. This you can basically think of if you're familiar with Python. This could be like modularizing your code into classes, different files and different packages, or C or C++, let's say you're also aware of classes and putting stuff in different files so that you're not polluting a single file. In Snakemake, if you want to have some code that is running as part of a rule, your first step would always to use the run directive, where you can put simply arbitrary Python code for a rule. And this is basically executed as is, and all the code lives in your snake file. If you just have some short snake files or some short code, this is typically very fine. However, what you generally want to do is that you want to outsource the scripts that you're writing from the snake file, which really just defines the logic of your workflow, into external Python scripts, which can then readily do everything that you would do in a normal Python script. So this is really useful. A second thing that is very useful is that instead of Python scripts or R scripts or Julia scripts, depending on what you like to use, you can also define, using the notebook directive, a Jupyter notebook, which is executed as soon as this rule is transformed into a job and then executed on the cluster. And this is, again, really, really nice because you can really immediately put your explorative, for example, data analysis into a set and fixed rule of your workflow. And an especially nice feature here is the --edit notebook parameter of the Snakemake executable, which basically allows you to interactively, as you run the workflow on test data on your local machine, open a Jupyter Notebook server, modify the notebook, save it, and Snakemake will then handle the rest automatically and save the notebook as part of your workflow. And it's just really nice and comfortable to develop in. Of course, if you have common rules that you need to use in many different workflows, for example, in biology or bioinformatics, this could be mapping of reads and so on. You don't want to repeat yourself all the time. Snakemake offers a solution to this by having a Snakemake wrappers repository, where you can use the wrapper directive, as you can see down here, and basically make use of already predefined rules which other people have developed and tested to, for example, quickly map reads using BWA to some reference. And if you go to this website that I mentioned up here, there is a long list of possible tools that you can use in your workflows. And if you have a favorite tool, it's of course also very easy to just add your own one to this repository. This is really just a short note that you can also include other snake files in your main snake file. This is really just like include statements in C or import statement in Python. It's nothing really magic about it. And then, of course, if you have an already existing Snakemake workflow, which you want to include in other workflows, there is also a directive for that called sub-workflows. Also, nothing too surprising. You're basically just importing functionality from already existing workflows into yours. And this gains an extraordinary amount of power if you consider that in addition to the Snakemake wrappers repository, Snakemake also offers you a Snakemake workflows repository. This is basically a collection of, again, tested and developed by other people workflows which deal with common things. For example, here in the field of bioinformatics, you can have existing Snakemake workflows that, for example, deal with RNA-seq analysis using Callisto and Sleuth, meaning that if you have to do this anyway, tons of times, you don't want to write your own whole workflow for this, but you can start and by modifying or by first cloning this existing workflow and then modify and tailor it to your own needs, which again speeds up development time tremendously. Now, we talked about different layers of modularization, which is great and an important thing in order to reach sustainable data analysis. But another important point, as already mentioned before, is scalability. And in order to be scalable, that is, in order to be able to execute the pipeline on different cluster environments, for example, you need to figure out, well, do they use Slurm? Do they use LSF? And how can I transform the resources that I define in my Snakemake workflow into cluster submission or in job submission commands that use the correct parameters and so on? And of course, this is always slightly cumbersome. So for example, here on the left side, you can see how this was usually done in the old days, let's say, where you would have to define, okay, I have my bsub, so this is for LSF, I have my bsub command, and then with -j, I tell it the name of my job. With -r, I can tell it how many resources I need. With -n, the number of cores that I provide to my job, and so on. So not really usable and not really adaptable and scalable to new cluster environments. Now, there is a new way, which basically condenses everything you see here on the left side into one single parameter, --profile, and then the name of your cluster environment, in this case, LSF. Well, what is this? There's yet another repository that Snakemake provides, which is Snakemake profiles. And this basically gives you predefined profiles for different cluster environments. You can see here on the left for Slurm and for LSF, where it basically predefines how to translate the resource requirements defined in Snakemake into parameters and job execution commands in the respective cluster environments. So again, just a nice way of dealing with scalability and portability of new systems. Speaking of portability, and together with that, of course, reproducibility, you run your pipeline on your local machine, you use your local software and software versions and so on, but now another person wants to run your workflow on his machine. So he probably either has to manually install everything you have installed or just give up in despair right away. This is typically the situation you have when you just have no package management at all and your workflow just uses whatever is currently available on the system. This is the first level and not the best level, as you can probably already imagine. A common level that many people like to use is to use conda-based package management, which basically means that for every single rule in your workflow, you also have an accompanying conda environment. So you just specify which software versions with which Python packages, R packages, and so on, which are available as conda packages, are used in the rule. And then whenever Snakemake executes your workflow, well, it just uses whatever is defined in your conda environment, and you don't have to worry about having to install anything manually yourself. The issue with this, of course, is you define the software version, but you're not defining the underlying operating system. So if you have your cluster in running Linux, which is commonly the case, but then you have some end user who wants to run your workflow on his machine, his local machine, which is using Windows, well, there might be some issues of packages not being available on both operating systems. So Snakemake also provides you with the ability to use conda-based package management together together with a containerized OS. So for example, together with Docker or Singularity, whichever you prefer. You can either use container directives to have the whole pipeline run in a Docker container, or if you prefer, you can also specify containers per rule. And then you can basically run the job in the container specified for the rule together with the software versions defined in your conda environment. And this really gives you a nice way of making everything as reproducible and portable as possible. Readability. Having other people understand what is actually going on in your workflow is of course also crucial in order for your analysis to be sustainable. For example, if you look at this snake file, maybe if you're not used to Snakemake, you wouldn't immediately notice what could be the issue with this. But if you look at it a little bit longer, you can see some inconsistencies. Like here you have spaces around the equality sign, down here you don't. Here you have the value of the shell directive in a new line, down here you don't. And different people have different coding styles. Which is the best coding style is of course always a great discussion to have, but I would argue consistency is really the most important thing. And there is an accompanying tool to Snakemake, which is called SnakeFMT for snake format, which takes as an argument basically just your snake file, and then based on the black Python formatter, in case you know this, provides you with a similar output for your snake file. So for example, up here it would say, well, you use single quotation marks, but you should use double quotes. Also, you need 2 empty lines between your rules. Also, you need no spaces next to your equality sign, and so on and so on. So this is also really nice if you integrate this together with GitHub Actions. So whenever one of your collaborator pushes in you to commit to your repository, Snake format can immediately complain and tell them that they did something wrong. And well, who doesn't like that? In addition to code formatting, we also have linting, which is not concerning the format of your code, but rather best coding style and practices when using Snakemake. So again, here you have this innocent looking snake file, but if you run snakemake --lint, which is the linting facility of Snakemake, it will generate this nice overview of what you could improve about your workflow. So for example, for your rule download, which is in line 11 of your snake file, well, you have no log directive defined, which means any output which is produced and which might help you debug potential issues is just lost. So read this text in order to learn more about this, or click this link in order to learn even more about it. So this is a very nice way of, especially when you're starting out using Snakemake, of providing, of programming snake files which follow best use practices, even if you haven't read the whole documentation beforehand. So also something which makes readability much easier for other people that try to understand your workflow. Now, I already hinted at configuration validation in the beginning when I talked about the skeleton of your Snakemake workflow. And this is really just a short note, because this is nothing special to Snakemake. This is just something that Snakemake makes really easy to do. Typically, as I said, you have your rule all, which defines what is supposed to be the end product of your workflow. And there you can expand your strings like figure underscore sample.pdf to whatever you define in your configuration file under the key samples. And this is really great, because then if somebody wants to use your workflow and wants to adapt it, they don't have to go into your source code and program new things, but they can simply open your static configuration file, put in new sample identifiers, and everything will work as expected. However, when, well, editing configuration files, things can go wrong, and this can lead to unexpected results. So validating configuration files is really something very useful and something that one should really do. And Snakemake provides you with this nice validate function from the utils subpackage, where you basically just pass your configuration object, which is automatically created by Snakemake if you use the config file directive, and a JSON schema, which basically describes how the configuration is supposed to look like. Now, JSON schemas are incredibly versatile, incredibly useful. I find them also somewhat complex because I don't use them that often, so I always need to read up on how things actually work. But to just give you a small example, and also down here a link to the very nice and very readable reference documentation. If you have a config.yaml, which has a key samples, which basically just defines a list of strings A, B, C, A, then you can define a config.schema.yaml, so a JSON schema, which is able to tell you whether the configuration you have on the left is correct according to the schema or not. And I don't want to go into too much detail. The only thing I want to mention here is that you can basically list the properties as you can see here, we have samples. It is of type array. The items are of type string, and the items need to be unique. And the description is whatever you want to put here. And if this key is not given, it can also default to a certain value. Now you may already notice we say, well, the list needs to contain unique items, but we have a duplicated one in here, namely A. So what happens if we try to validate this? Well, we will have a workflow error in line 5 where we do the validation, because we have an error in validating the config file because this list has non-unique elements. So this can basically immediately tell you where you went wrong in your configuration file and makes it rather easy, as soon as you understand this output, to fix it and to make your workflow work again. And then as a last note, I have no idea how I'm doing with time, but I hope it's still all right. Automated using unit testing. I guess most of you like testing or learned to like testing after things went horribly wrong when not doing testing. And again, here you have this whole philosophy of having integration tests on the one side that really test the whole software that you're developing end to end. And then on the other side, you have unit testing, which really tries to test individual components as small as possible of your software. And then you maybe also have some more esoteric testing, things like mutation tests, where you mutate parts of your source code and then hope that some test fails because, well, you just changed your software in a way which is not supposed to happen. But anyway, I digress. What is really the important thing here is that Snakemake allows you to quickly and efficiently, without much of a hassle, generate automated unit tests for a given workflow. The idea is that you just have your normal Snake file with some sample small testing data. Then you run it once by executing snakemake-j1 to just run it on a single core. Your workflow runs through, it finishes successfully with your test data, everything is nice. And now you want to say, all right, this is good. I want to test and ensure reproducibility of exactly this run. And then I want to start modifying things without breaking what I have already managed to do so far. And Snakemake provides you with the -- generate unit tests parameter, which takes your Snake file and the successful workflow execution, and for every single rule, so all, download, and work, generates a single unit test, which ensures that, for example, in the case of the rule work, given this input, when you execute whatever you defined out here, you will generate this output. Now, this is no magic. This really just facilitates existing Python testing frameworks, such as, for example, PyTest. And for a single execution of this generate unit tests command generates or creates the .tests subdirectory where you have some, well, you have some helpful utilities, whatever, that doesn't matter. But for every single rule in your Snake file, you have a test_all for the rule all, test_download for rule download, and test_work for your rule work, together with the input data and the expected output data. And then simply what Snakemake is doing is it sets up this test, which creates a temporary directory, puts everything into a working directory, namely the data that is needed as input, and then in the end also knows about the expected output, and then just runs Snakemake and compares whether the expected output is equal to what Snakemake generated in this run. And because, as I said, you are basically using PyTest to run all of this after the fact, you get these nice summaries of your tests, and you immediately know after you've changed something whether a test broke a rule or not, which is, again, just really nice if you want to make your whole software stack somewhat stable and, well, usable for other people. Now, there are, of course, tons of other things that one could talk about. If you want to know more, I would recommend that you take a look at the paper that I mentioned in the beginning, because Many things are mentioned in there. Also, take a look at the documentation of Snakemake. Everything is described in quite a lot of detail on there as well. There are reports. So I'll just list these things to give you a flavor of what is to come. There are automated reports where you can mark certain output files from certain rules to be included in an automatically generated report in the end. So you can quickly observe what has happened in your pipeline and quickly understand what is going on without having to do anything manually about it. There are checkpoints, which basically, and this is now a slightly technical point, allow you to reevaluate the job DAG during the execution of your workflow. This is, for example, useful if you have a certain rule which generates an unknown number of output files. For example, if you're doing clustering and then you determine the number of clusters, and then you want to execute another rule or another job on every single cluster. And you don't know this a priori before executing your workflow, but only during the execution of your workflow. So checkpoints are really crucial in allowing Snakemake to deal with this. There are shadow rules. Shadow rules basically take a job away from your local file system where Snakemake is currently running and place it in an isolated one, meaning that if you have a rule which generates tons of output files that you're all not interested in, well, you don't have to care about removing all of them manually, but you can just run everything in a shadow rule, and Snakemake will take care of cleaning everything up. Piping results between jobs. Well, sometimes output files are important, but not important enough to be actually stored on disk because they are also very huge and would take up all your cluster quota. So what this allows you to do is to basically take the output of a certain job and immediately pipe it into the execution of the second job coming after it. So a large file doesn't have to be stored on disk, but can be readily consumed by a subsequent job. There's also stuff like Google Life Science integration, in between workflow result caching, which is, for example, particularly useful when you are in the bioinformatics realm and you, well, have to index your human reference genome again and again, and it doesn't really change between workflows. And then you can use this nice facility here. If you have your workflow set up and ready to go, snakemake --archive with a subsequent upload to, for example, Zenodo to generate a DOI for your analysis gives you a really nice way of sharing what you have done and making it accessible to others. There is multiple workflow monitoring using Panoptis, which basically allows you, if you have a cluster environment, to have many different users run all the Snakemake work simultaneously. Then Panoptis basically gives you a nice way of seeing what is actually going on as each workflow progressed without having to really go into every single directory and follow every single process in detail. And as I already said, there are many more great things. If you have any questions or suggestions, I'd be happy to chat about them. And with that, I would like to conclude my talk. Thank you very much for listening.